Hello, Mr. Betts here. Let's take a look at an example, a particular example where we are looking at position, velocity, acceleration, displacement, all that stuff for a particular function. So we have an object that's moving along the x-axis. So remember, x-axis is a horizontal axis, positive values to the right, negative values to the left. And the position of that object on the x-axis is modeled by this function for values of t between 0 and 5. So the position is going to be measured in meters, so that's going to be our units along the x-axis, and the time is going to be measured in seconds. So this function is just telling us where the object is during that 5-second interval from t equals 0 to t equals 5. So we've got 5 questions here that we want to answer. We can kind of scan through those and look at what we're doing here. We want to know the position of the object at different times. We want to know the displacement of the object, so we'll talk about what that means. When is that object at rest? When is it moving to the right? We could also answer a similar question. When is it moving to the left? When is it speeding up? So remember, speeding up is when the speed is getting bigger, not necessarily the velocity getting bigger. And then distance traveled. And distance traveled is going to be a little bit tricky. It's different from displacement, but we should have the tools to be able to do that. So let's start here with just position of the object at 2 different times. So the position at 0 is going to be given by x of 0, which is going to be 0 cubed minus 6 times 0 squared plus 9 times 0 plus 7. That's a nice easy one. That's just 7. I don't want to give just a number, though. It's going to be at the 7-meter mark. So this does not mean that the object has moved 7 meters. It just means that along the x-axis at t equals 0, it's going to be at 7. At t equals 5, we're going to plug 5 in. It's going to be a little bit trickier. 5 cubed minus 6 times 5 squared plus 9 times 5 plus 7. This is going to be negative 25 plus 45 is 20 plus 7 is 27. So after 5 meters, or I'm sorry, after 5 seconds, it's going to be at the 27-meter mark. What we don't know is what's happening in between. We're going to answer some questions about that later, but it's starting here. It could be moving to the right and to the left. We don't know, but it ends up at the 27-meter mark after 5 seconds. So then the displacement during that 5-second interval is going to be x of 5 minus x of 0, which is going to be 27 minus 7, which is 20. And again, that's 20 meters. So what this displacement is telling us is that from where the object started, it moved, and remember this is a vector, so it's a positive 20, so it moved in the positive direction 20 units. And that makes sense because it started at 7 and it ended up 20 meters to the right, so its displacement is going to be 20 meters. The next question, it says, when is the object at rest? So at rest is talking about the motion of an object, not where it is. So when we're talking about the motion, we want to know where is the velocity equal to 0. So the first thing we need to do is find the velocity. And the velocity is going to be given by the derivative of the position. We know how to take the derivative. Now we are taking the derivative with respect to time here because that's our independent variable. So it's just a regular derivative using the power rule, constant multiple rule, and sum and difference rules. So our velocity is going to be given by that. So just kind of thinking about what this means, if we plug, say, 0 in for t, that means that the velocity at 0 would be 9 meters per second. So when this object starts at t equals 0, it's moving to the right 9 meters each second, but that's an instantaneous rate of change. We want to know when it's at rest, when the velocity is equal to 0. So what we're going to do is we're going to set the velocity equal to 0 and solve that equation. So we can factor and factor. and we get t equals 3 and t equals 1. And we want to be careful in problems like this because this model is restricted to certain time values. If we got an answer here that was outside of that range, we wouldn't want to include it. However, t equals 3 and t equals 1 are both in that range, so we would say the object is at rest at t equals 1 second and t equals 3 seconds. So it starts at t equals 0, 1 second later, it pauses. 3 seconds later, 2 seconds later, so 3 seconds after the start, it pauses again. So at those two times, the object is at rest. I do want to point out, and we're going to need this later, that when the object is at rest are the only times that the object can change directions. So if the velocity is positive like it is at the beginning, and we know it's positive at the beginning because v of 0 is 9, then we know the object's moving to the right at least until t equals 1. Then I don't know at that point if it's moving to the right or to the left, but between t equals 1 and t equals 3, since it's not at rest during that time, it's going to be moving in the same direction during that interval. And then between t equals 3 and t equals 5, it's going to be moving in the same direction again. So I know that during this 5-second interval, there's only 2 times where it can actually change directions, and that is going to be important to do a later part of this problem. During what time interval is the object moving to the right? So we know that if the velocity is, not equal to, but greater than 0, then it's moving to the right. So based on what we just figured out in the last part where the object is at rest, those are the places where it could change between moving to the right and moving to the left. So what I'm going to do here is I'm going to make what's called a sign chart. So my sign chart here is going to be for the velocity, and all I really care about capturing in the sign chart is whether the velocity is positive or negative. So I'm going to make a number line here. And this number line is not the x-axis, but it's going to be the time axis. And I'm going to put some significant points on here. So first of all, we're only looking at the interval from t equals 0 to t equals 5. But in this last part here, we also said that at these 2 times here, at t equals 1 and t equals 3, those are the only times where the object could change directions. So I know that between 0 and 1, and between 1 and 3, and between 3 and 5, that the object is not changing directions. So that means that between 0 and 1, the velocity is either always going to be positive or it's always going to be negative. And we actually already found out that the velocity at 0 is 9, so that's positive. So on my sign chart here, I'm just going to put a plus there. And what that tells me is the velocity is going to be positive everywhere between t equals 0 and t equals 1. At t equals 1, the velocity there is 0, and it could possibly change from positive to negative at that point. So what I want to do is I'm going to pick a point anywhere on this interval here. It doesn't matter what point I pick, so I'm going to pick t equals 2. And let's figure out what the velocity is at t equals 2. So the velocity at t equals 2, remember we're plugging it into that velocity function that we found in the last part. So it's going to be 3 times 2 squared minus 12 times 2 plus 9. And so that's going to be 12 minus 24 is negative 12, plus 9 is negative 3. So this negative 3 tells me that at t equals 2 here, the object is moving to the left. All right, and since it's moving to the left there, and the only times it's at rest are t equals 1 and t equals 3, it has to be moving to the left during that whole interval. Then between 3 and 5, we can do the same thing. So velocity at 4, let's say, is going to be 3 times 4 squared. Minus 12 times 4 plus 9. 4 squared is 16 times 3 is 48. minus 48 is 0, plus 9 is 9. So the velocity at 4 is positive, and it's going to end up being positive everywhere between 3 and 5. Okay, so essentially what I'm doing here is I'm just picking points on each interval, and I know that the velocity is going to have the same sign at every point on the interval. And I know that, again, because the only places where the velocity can change is going to be where the velocity is equal to 0. So based on that, the velocity is positive between t equals 0 and t equals 1, which means that when the velocity is positive, it's moving to the right. When the velocity is negative, it's going to be moving to the left. And when the velocity is positive, it's moving back to the right. So let's write out our answer here. So moving to the right, we'll say the object is moving to the right between t equals 0 seconds and t equals 1 second, and between t equals 3 seconds and t equals 5 seconds. Okay, so we're kind of getting a better picture of what the motion of this object looks like. So we know that the object started, if we look at the x-axis, at a position of 7. We know that it moves to the right for some period of time. Then we know that it moves to the left for some period of time. And then we know that it moves to the right again for some period of time. Now, what we don't know is how far it moved in each direction, but we do know that it's changing directions at t equals 1 and t equals 3. So that's actually going to help us in a later part of the problem. But first, let's figure out when the object is speeding up. So remember, speeding up, there's two cases where something's going to be speeding up. That would be when the velocity is positive or it's moving forward and the acceleration is positive, or it could be where the velocity is negative and the acceleration is negative. So we already have a sign chart for the velocity. I'm going to recreate that here real quick. By the way, when you're making a sign chart, you don't have to worry about making sure that it's scaled correctly. Now what I want to know is during the times when the velocity is positive, between 0 and 1 and 3 and 5, is the acceleration also positive at any points during those intervals? So to do that, we're going to need the acceleration, which is going to be the derivative of the velocity. And we've already found the velocity by taking the derivative of the position. So this is going to be 6t minus 12 is going to be the acceleration. And to start with, if I want to know when the acceleration is positive or negative, I'm going to start by figuring out where it might change from positive to negative or vice versa. I'm going to do that by finding out when it's 0. So the acceleration is going to be 0 at t equals 2. Oops. So the acceleration equals 0 at t equals 2. And so what that tells me is the acceleration might change signs at that point. So if it's 0 at 2, that means that to the left of 2, it's either going to be positive or negative, and to the right, it's either going to be positive or negative, but it's going to be the same everywhere to the left and to the right. So I'm going to make my sign chart for velocity should not have been v prime. I'm going to make a sign chart for acceleration. So same time axis going from 0 to 5, and I'm going to put 2 on here. So to the left of 2, I'm going to put in the point 1 here. So the acceleration at 1 is going to be 6 times 1 minus 12, which is negative 6. So between 0 and 2, the acceleration is going to be negative. It's negative at t equals 1, but also at t equals 2 is the only place where it's going to change signs, because that's where it's 0. Between 2 and 5, let's say 3. 6 times 3 minus 12 is positive 6. So between 2 and 5, the acceleration is going to be positive. So that tells us the velocity is decreasing from 0 to 2, and then the velocity is increasing from 2 to 5. Okay, so if we put those two together, where is the velocity positive and the acceleration is positive? Well, the acceleration is positive between 2 and 5. The velocity is positive between 3 and 5. So this is going to be on the interval from 3 to 5. Where is the velocity negative and the acceleration negative? Well, the acceleration is only negative from 0 to 2, and the velocity is negative from 1 to 3. So where those overlap is going to be between 1 and 2. So this is going to be on the interval from 1 to 2. Okay, so between 3 and 5, the object is speeding up because the velocity is positive and the acceleration is positive. So the velocity is positive and increasing. Between 1 and 2, it's speeding up because the velocity is negative and it's decreasing, so it's becoming more negative. So in combination, we're going to say the object is speeding up between t equals 3 seconds and t, that's really sloppy, sorry, and t equals 5 seconds. And it's also speeding up between t equals 1 second and t equals 2 seconds. Whew. Okay, last one. The total distance traveled by the object over the 5-second interval. So if you remember back in part C, we figured out that the object was moving to the right for the first 2 seconds. Then it was moving to the left for the next 2 seconds. I'm sorry, that was 1 second. So for the first second, it's moving to the right. For the next 2 seconds between t equals 1 and t equals 3, it's moving to the left. And then for the next 2 seconds, it's moving to the right. Now, my magnitudes here I know are not right because, well, it could be, I guess. We know it's starting at a position of 7 and ending at a position of 27. What we don't know is how far it goes on each of these intervals. So if you remember, if the object's moving in one direction, the distance traveled and the displacement are going to be the same. So essentially what I want to do is figure out how far the object traveled on each of these intervals. So for this one, I want to know what is the position at 1 minus the position at 0. Okay, so the position at 1 is going to be what we get when we plug 1 into this function, which is going to be 11, minus the position at 0 is 7. We figured that out earlier. So during the first second, the object moves to the right 4 meters. Now, during the next 2 seconds, we're going to get a displacement that we're going to expect this to be negative, just thinking ahead here. X of 1 we know is 11. X of 3, let's do a little math to the side here. So it's 3 cubed minus 6 times 3 squared plus 9 times 3 plus 7. So this is 27 minus 54 is negative 27 plus 27 plus 7. So it actually turns out that it is going to be at 7 minus 11 is negative 4 meters. So the displacement is negative 4 meters, so it went to the left 4. But when we're talking about distance traveled, we're going to add on that 4 meters. So during the first 3 seconds, it moves to the right 4, and then it moves to the left 4, but it moved a total of 8 meters, even though it ended up back where it started. Okay, and then x of 5 minus x of 3. Remember, x of 5 we said is 27. X of 3 is going to be 7, so it moves to the right 20 meters. So the total distance traveled is going to be the distance that it traveled during each of those segments is 4 plus 4 plus 20. So it moves a total of 28 meters. Okay, so we knew from the very first part of this problem that this object ended up 20 meters to the right of where it started, but during the course of its motion, it actually moved a total of 28 meters in both directions.